if after the raw data analysis the performance matrix was not well enough, then we will go for feature optimization technique. And the feature optimization techniques basically three types. One is feature reduction technique, and PCA, principal component analysis, and LDA, linear discriminant analysis are the two feature reduction technique. In feature reduction technique, but in feature optimization technique, we have to be careful that we cannot do any changes in our target or output variable. And three type of feature optimization has: one is feature reduction, secondly feature selection, and the lastly feature importance. And the feature reduction type is PCA and LDA. PCA, these are the two feature reduction technique, here is two feature selection technique, and finally feature importance technique. PCA, principal component analysis, we can use for regression or continuous analysis, and also classification dataset. But LDA we cannot use for regression analysis, it is for classification analysis. For feature selection, there are two type techniques has: one is RFE, recursive feature elimination, and MRMR, minimum redundancy, minimum relevance. All of these we can apply for regression or continuous dataset also, as well as the classification dataset. Feature importance technique is basically we can use for T-based algorithm, and we can use feature importance techniques for regression and classification also. There are another two types of explainable AI technique. One is known as SHAP and another is LIME. We can use these two things for regression as well as classification dataset. So initially we will try to learn how to apply PCA. For this we will go to Colab, and in feature reduction technique, the name of column and value of each column will be changed, and the initial column of dataset are very important for further analysis. So we have to take the first portion of columns, and in three feature optimization technique, I mean in feature reduction, feature selection, or feature importance, we never change our output or target variable. So initially we open Colab. Initially we will learn how to apply PCA, and for PCA, file, upload notebook, then browse. This is the PCA code that I already wrote it previous time. So initially we press the file option or connecting option. Then after connecting, load dataset. PCA we can apply for continuous and classification datasets. So choose file. This is our regression dataset. Open it. And in this regression dataset, first, second, third, fourth, fifth, and sixth column, up to sixth column is our input section, or this is known as also feature, and the last section WTY, it is our target variable. So, and the first column, the index value is 0, second column index value is 1, 2, 3, 4, 5. This is our index value, and for the last or output column, the index value is 6. So we have to change in our code. So we import here necessary files and packages. So the name of our file we have to paste here, and initially this is the indexing value for first column, and this is the indexing value of our output column, and the number of input column is 6. So you can replace it based on your dataset. Then run this code. Cumulative explained variance. Up to 80% of cumulative explained variance will take the number of columns. So based on 80% data and go towards x-axis. So it is almost 2.6. So the further number is 3. So it will take 3 number of columns as a principal component after analyzing a principal component analysis. So this is our first code of principal component analysis. And in second code, our columns value will be changed. And for principal component analysis, you have to use a standard scalar or pre-processing technique. Terminate other section, okay. Then again run this code. Copy the name and paste here. Our 0 is column 1 indexing value is 0 and 6 is the column 6 or output variable indexing number, and number of 6 is the number of input column. Then choose file. Here the clean data is our regression grid. So choose here and copy the name here and replace here and here. That in previous slide it suggests that the principal 3 columns as principal component analysis. So we replace it here 3 columns only as principal component analysis, and here also 6 is replaced by 3. Then run this code. Then one new dataset, transform dataset. You can see the left side. This is our transform dataset. So in this dataset, you can download here. This is the principal component 1, principal component 2, and principal component 3 rows. This is the most important rows. And from the raw dataset, you have to copy the output or target column and paste here. This is the end of our principal component analysis. Then copied, and then using this Excel sheet or CSV file, you have to analyze based on our second class, I mean previous class. So we completed PCA analysis, then LDA. This LDA is only for the classification dataset. If we import here clean dataset, I mean for regression value, then it will not work. So initially you have to load the dataset. Then similarly, 0 is the indexing value of 1, number of input variable, and indexing value for output. Then from this code, you can up to 80%. You have to choose the number of columns that you take for a further analysis, and this is the second code for LDA. Initially load the dataset. Then you have to change the name of your dataset. Then this is the same as previous manner, standard scalar. In all of feature reduction technique, standard scalar have to used because to convert the dataset in a singular in a specific range, then you can change the name of LDA1, LD2, LD3. Then run this code same as PCA. So now we will move to feature selection technique, and two feature selection technique is RFE MRMR. So initially you have to reconnect, then import file, choose file. This feature selection technique you can use for regression as well as for classification also. You have to install PyMRMR. So not pip install PyMRR. Then the name of our dataset, copy and replace here. This is the output variable or decision column name, WQI. This is case sensitive issues. So capital word W, capital W, Q, capital I. We have to replace here the capital of WQI. And this is the features. It is better to select initially the component is 1, then 2, then 3, then 4, so on. And for each file or each Excel or CSV file, calculate the performance matrix and evaluate which is the best effective ways. So initially run taking the 5 number of component, and it suggests that this is the MRMR process. When you take the 5 number of column, it suggests that total alkalinity, total hardness, EC, and TDS is the most effective column. You can change it from like 4 also. When you use 4, then definitely it suggests total alkalinity, total hardness, and EC. Basically, when you select 4, you can see here 3 component. When you select 5, you can see here 5 component. Basically, the remaining 1 component is considered as the output component. So always you will get one minimum 1 value, which column you will select as a feature selection technique based on MR process. This code is for RFE process. So for that case, initially you have to rename here file name and the output column name. Then you can select the feature also. Like let's say we select initially 4 features, then run this code. When you select 4 feature in RFE method, it shows 4 effective column, most 4 effective column, pH, iron, TDS, and total alkalinity. When you select here 3 columns, it selects pH, iron, and total alkalinity is the most effective column. This is the feature selection technique. So from our raw dataset, without these 3 input, the remaining 3 input we will delete, and the final dataset is then from our previous classes. And then we will move to the feature selection technique. In feature selection technique, initially we have to load the dataset. And here from here you can delete the files. And the code is basically we write for regression analysis. For classification analysis, you can change using AI. Little portion of code you have to change only. Not a big things, I think. So initially we'll reload the set. The name is copied and pasted here. The target variable is WQ. I already pasted here. Oh, this is also the feature selection that I already mentioned or discussed. So this is our feature importance technique. In this feature importance techniques, the gives important score for each factor. So initially for this code, we run or reconnect this code, and this is suitable for decision or tree-based models. Manage session, terminate other sessions, close. Then run the code again. import pandas, matplot, sklearn, trend test split. And load the dataset. This is our regression dataset, cleansed regression dataset. Then already I changed the name here, and this is our output column name. And you can change if you want to use random forest regression, that is okay. But if we want to change decision tree regression, extreme tree regression, or any other linear models or support vector regressions, that you have to change the model name here. The remaining things is okay. Then run this code. And here the importance factor for iron is almost 0.6, and the total hardness has less scored, I mean almost zero, so no effect on the hardness based on the feature importance technique. So we have another two process to get the importance of columns or in columns. One is the line, another is the shape figure or line shape figure. This is the code. We have to reconnect and run this code, then upload our dataset. Here we already changed the name. This is the indexing value of first column, number of input column, indexing value of last column, and choose file, clean dataset. Already here also okay. And run. If you want to, instead of linear regression, you can use the another models also. Only you have to change the name here. And okay. No need to change anything. In the last portion, you will get two figures. One is predicted versus actual figures, and the another is line figure. This is very important for any research, but I think I have to change in this code one thing, so because the background is black. If the code shows the white background, it looks beautiful. So definitely in this code, I have to one thing, one change I have to do already. This is the shape file. Initially reconnect, then load dataset, and similarly change the file name and indexing value of first column, number of input column, indexing value of last column. You can change the model name here. Let's say or you can change here a model name, and this line and this shape code is for regression and as well as the classification data is also. For regression analysis, the performance measuring parameter is MAE, MSE, RSME, R square. But for the classification analysis, the performance measuring values are different. So if you want to use this code for the classification dataset, then you have to change this portion also. Okay, this code was not, I mean, shows some error because in previous code, this is a previous code, I didn't run it, so I ran it. It's okay, and now it will also. I think it also okay. Then this is the shape value. Use ChatGPT to get the background or what is the meaning of this shape value. It shows importance value on kind of. So for today's session we completed here. In our next class we will try to learn how to use a normalization technique, and then in the last class we try to learn how to analyze the feature classification dataset. So thanks everyone. And if you need the all code, give a comment in comment section. I will provide all the code.